Good morning, everybody. Today we have to discuss about the electromotive force, and in that topic, in the previous class we have to discuss about the functioning of galvanic cell. Again, the remaining part of the galvanic cell and remaining part of the functioning of the galvanic cell we have to discuss it in this session for the second semester diploma students. So we know the galvanic cell. We know the how can we have to construct the galvanic cell. Galvanic cell is a in between two different metals. We have to construct it and respectively electrolytic solutions. Then we have to maintain the one of the circuit. In that circuit we have to observe the deflections which is generated the power, and we have to measure that power by the voltmeter. So the galvanic cell constructed by using any two metals are also two non-metals, or one metal and one non-metal also. Then more reactive metals act as a anode and less reactive metals act as a cathodes. So what is the role of salt bridge in the galvanic cell? It is the role of salt bridge in the galvanic cell. The salt bridge is a U-shaped tube which is filled with the gelatin gel prepared from the solution of potassium chloride or ammonium nitrate. And in the galvanic cell, the two solutions linked through a salt bridge, but the solution should not mix each other. Then we have to make the U-shaped tube. The salt bridge is made with the U-shaped tube, and that tube will be filled with the gelatin gel prepared from the solution of potassium chloride and ammonium nitrate. In the galvanic cell, two solutions are linked through a salt bed, but the two solutions does not mix each other. The electrons released by the zinc atom can be flowed to the copper rod through external circuit. So when the electrons are loosed by the zinc, then automatically that electrons are moving from zinc to uh, zinc anode, which is the anode, to cathode copper rod by oxidation reaction and reduction reaction. Then these electrons are reduces some of the copper plus 2 ions from the solution. So at the copper rod, copper solution is there. In the copper solution, copper sulfate solution, copper plus 2 ions are there. That copper plus 2 ions are reduced with the electrons which are coming from zinc rod. Zinc rod. So when it is happens from sometimes, the copper sulfate solution gets the negative charge due to the reduction of copper plus 2 ions. So in this meantime, zinc sulfate solution becomes a positive due to the formation of zinc plus 2 ions from the zinc rod. Zinc rod. What we have to observe here, copper plus 2 means something, but positive charges going to be negative and negative will be going to be positive. It will be happening when it will be happening then automatically the generating of power will be stopped. So to avoid that situation, we have to maintain the U-shaped tube. That U-shaped tube will be again fulfill the electrons. So why? Because it allows only electrons and ions only, does not mixing the physically, and where the electrons or ions are accumulated on the electrodes, that will be moves this side and that side, and again it will be continuously generate the power. So, and this accumulation of charges in the two solutions preventing further flow of electrons. Further does not flow the electrons when accumulated the charges in the two solutions. Hence, the reaction in the cell are stopped if salt bridge is not used. If the salt bridge we have to use in the solution, this preventing the accumulation of charges in the two solutions, then automatically that reaction will be in between the two electrodes will be continuously. When that reaction will be continuously, then power will be generating the continuously. The salt bridge if used provides flow of ions towards the oppositely charged electrodes. The negative ions moves from the copper sulfate to zinc rod. The positive ions moves in the reverse direction, hence the charges are neutralized at the electrodes, so the electricity generates continuously. Thus, salt beds prevents the accumulation of charges on respectively electrodes. So, the role of this salt bridge is very important. So it will be plays the important role in the galvanic cell. Without that galvanic cell, we not using the long time of the galvanic cell. So galvanic cell and role of the salt bridge, and this is the total functioning of the galvanic cell. In the functioning of the galvanic cell is when we have to construct it and measures, and this galvanic cell is very useful to in our daily life. We are using the vehicles, automobiles, and nowadays in our home needs, and different types of batteries we have to making the different types of batteries, that whatever they're here, primary batteries and secondary batteries, and so many batteries we have to using. And so, dear students, listen here. Separate question also asking about the role of the salt bridge. Here, question is very important. For the long essay questions, just simply they was asking as like that in the board examinations question paper. Explain the construction and functioning of galvanic cell. For the short question type, define the galvanic cell. How can you define? In which cell spontaneously oxidation reduction reactions are takes place. When two different electrodes are connected each other and generate the power is called as galvanic cell. Galvanic cell. Okay, simply say that. And next one question is, write the role of salt bridge. Write the role of salt bridge for the 3 marks or 5 marks. Write the role of salt bridge. You can write the total points. Then you have to, how can it is prepared the salt bridge, how can we have to make the salt bridge. The salt bridge it is a u-shaped tube filled with the gelatin gel prepared from the solution of KCl and ammonium nitrate. In the galvanic cell, two solutions are linked through a salt bridge, and electrons released by the zinc atoms can be flowed to the copper rod, and simply we have to say that about the salt bridge. Salt bridge link the two solutions to allow the electrons or ions through it, but it will be does not mixing the physically mixing of two solutions. First point is preparing of the salt bridge. Second point is does not link the physically mixing of, it's link the two solutions but does not mixing of physically mixing of two solutions. And third one point is it is preventing the accumulation of ions on the electrodes. And fifth one point, and it will be help to continuation of oxidation reduction reactions at electrodes due to the preventing of accumulation of ions, and it will be help to power generate continuation of power generation. So this is the salt bridge. Thank you everybody. In further class we have to discuss about the how can we have to represent the cell cell reaction and electrodes, and what is the electrode potential, what is the standard electrode potential, what is the electromotive force, how can we have to calculate the electromotive force, and electromotive force. Due to the electromotive force power will be generated. So these topics will be we have to discuss in the further classes. All of you go and refer the books and read it. In the next class, we have to discussing about the electrode potentials and elec- galvanic cell reaction, galvanic cell representation, and oxidation reduction potentials. How can we have to calculate the EMF of a cell? Okay, thank you.